A simple computer runs this elevator system. It knows to park the elevators on the ground floor in the morning and on the top floor in the evening based on the pattern of usage. But what if everyone here were to suddenly go on the night shift? Well, the elevators would still park themselves the same way because the computer would require artificial intelligence to automatically adjust to the changing conditions. What exactly is artificial intelligence, and does it even exist? We'll get the answers to these questions as we take a look at artificial intelligence on this edition of the Computer Chronicles.
The Computer Chronicles is made possible in part by a grant from AFIPS, the American Federation of Information Processing Societies. AFIPS, sponsors of OAC 86, the nation's leading conference on business technology. For conference information, call 800-OAC-1986. Exploring today's business solutions. Additional funding is provided by McGraw-Hill, publishers of Byte. Byte's detailed technical articles on new hardware, software, and languages cover the latest in microcomputer technology worldwide.
Welcome to the Computer Chronicles. I'm Stewart Cheifet, and this is Gary Kildall. And Gary, this is a product called Ractor. Ractor claims to be able to have an intelligent conversation with you. I just asked it if it uses artificial intelligence, and it's so dumb it can't even figure out what I'm asking it, actually. The makers of Ractor claim it has AI, but they say that's artificial insanity, which may or may not have anything to do with artificial intelligence. Gary, seriously, on AI, this is one of those areas in which there have been so many promises, but apparently not that much delivery. Are there really any artificial intelligence products out there today?
Well, Stewart, the real beauty of artificial intelligence is that it's a moving target. Once the basic research results in a product, it's no longer interesting artificial intelligence work. 20 years ago, Samuels had a checker playing program that was considered good basic AI research. Today, it wouldn't even make it into a Macy's store. So we hear about products nowadays that really have things like, well, they claim things like natural language processing, expert system capability, things of that sort. We have to now figure out what's the fluff and dazzle and what's the substance.
Well, we're going to try to find out today by taking a serious look at artificial intelligence. We'll meet some of the top names in the country in the AI field, and we'll see some fascinating demonstrations of artificial intelligence at work. We're going to begin by taking a look at a vision recognition system that uses AI to interpret what it sees.
Human beings are equipped with stereoscopic vision, a distinctive feature that allows us to judge distance and the relative placement of objects. In addition, humans know how to identify the features of a landscape by color, shape, or placement. But how can a computer be programmed to do the same with the same limited information? In Palo Alto, California, a machine vision project is underway to automatically produce digital terrain models by scanning stereoscopic photographs of the Earth's surface. Working from illumination densities and reflectance values, the terrain modeling system, with some human assistance, can calculate an image from any point of view. It can then synthesize a flight path through the terrain based on any chosen route. While the process of creating topographic maps is simple geometry for a human being, scanning a photograph, no matter how detailed, is full of ambiguities. Tall objects obscure smaller ones. Repetitive patterns can be confusing, and forms can be misinterpreted. To overcome these ambiguities, the SRI project is experimenting with artificial intelligence. The goal is to develop a program that can look at the global constraints of an image, the parts in context with the whole. Like much of today's government-funded AI research, this program is slanted toward military applications. But its future potential will help us recreate more exotic views, from the inside of a human body to the outside of the moon.
Joining us now in the studio are Dr. Harry Tennant, senior member of the technical staff at Texas Instruments in Austin, Texas, and Dr. S. Gerald Kaplan, principal technologist for Lotus Development Corporation of Cambridge, Massachusetts. Gary?
Jerry, the first question. AI is one of those things that people are appending to their products now to make them fancier, add the frosting, and to make them sell better. It has a chance of, I guess, in a sense, being misused. And how do you characterize AI in this new technology you're working with?
Well, really, artificial intelligence is a fundamental software technology that's of interest primarily to people developing software. It's not an end-user product in and of itself that one would want to sell or to... there really isn't much of an AI market except for the tools market, and we're going to see some of the tools here today.
Okay, characterize some of these things. What are the kinds of things that you'd say AI can add to?
Well, what it
products?
can add, well, first you have to understand what it is. It's really methods for programming using symbols and describing their interrelationships, and then being able to reason about them to reach some kind of conclusions or enhance some existing type of application. What we're going to see in the next few years is a continued growth in the utility and intelligence, if I can use the word loosely.
Making programs a little bit easier to use and a little more intelligent.
A little more intelligent.
Okay.
We're going to begin to see out of Lotus, certainly, and other companies, programs that begin to know more about their intended use, and that can help the user by interpreting the user's intentions as opposed to executing the user's commands.
Okay.
Okay, Harry, that's a perfect introduction to what you've got
Give us
here.
an example of it.
You've got a natural language system, one part of AI first, and show us what that is.
That's right. What we have is a way to ask questions of the computer in English so that the user doesn't have to learn an arcane computer language before he gets started. In this case, what I'm going to be doing is building a sentence up in this portion of the screen out of words and phrases that I select from the menus down below. For example, the sentence starts with show. Show the average number of days of sun in, and now I'll choose a city, in El Paso. Now I've got a complete sentence and I can ask for the answer. Show the average number of days of sun in El Paso, 319 days. Now, the benefit of this is that somebody who doesn't know anything about the kind of database that we're interfacing to or anything about how to command that database can come up and immediately see what kind of information is in there and can immediately find out how to get the information out.
Harry, can you actually do the inverse of this process and type the sentence in immediately, or is it something you select off the menu and construct the sentence?
You select off the menu and construct the sentence. I had been doing research in the area of natural language processing, which is the act of typing in the sentences and so on, for quite a few years before I came up with this approach. The benefit of this approach is that 100% of the queries that the user puts in will be understood because the user finds out what kind of sentences he can put together, what kind of things the system is going to understand.
How would you compare this with products that say where you actually type sentences in and there's algorithms and heuristics that actually go in there and try and figure out what the sentence is? Is this the same kind of a product or is this a different kind of thing?
Yeah, what we did was if you take away the menus, behind the menus lies the exact same technology that's in the conventional natural language systems. All we've done, there are limitations to any natural language understanding system, and all we've done is to reveal to the user what the extent of that system is and what the limitations are.
So if one were to peel this layer off, you could actually start typing sentences and it would understand that. So the underlying algorithms are like that then?
That's right.
Okay.
Okay, Harry, you have now an expert system you're going to show us, and I know
Yes.
you've got to reload there. If you could do that for a second.
All right.
And Jerry, I'd like to ask you now, we're trying to get a handle on this definitional problem. Now, what we just saw, would you call that artificial intelligence?
I would say that that's really in the category of a tool, and what you've seen is an application of that tool to querying a database in particular. That's all I would say.
So who knows?
I really don't think it's accurate to say one thing is or is not an AI product. AI is not something special that you add to an existing program. It's an approach to programming and creating programs that are flexible or useful or solve problems which previously might have required some kind of human intelligence or attention.
Well, it's certainly the case that there is a gray area there between what we could call a user interface and something that really understands the sentence.
Yes.
And that's,
I think I would define AI a little bit differently from what we've heard. AI, when it started out in the early 50s, was really a set of problems. How can we make computers reason? How can we enable them so we can talk to them or let them see? Or other problems like that that we recognize in humans that we do, and we associate that with intelligence. How can we take that same capability and put it into our artifacts, into our computers? Well, it's this range of problems that make up what is AI. We've developed a whole collection of technologies to address those problems. The natural language that I've demonstrated is one of the approaches. There are many, but one of the approaches to that sort of problem.
Okay, show us the expert system you
is
have
another.
here
Now, what we have here is a technique for decision-making and making of judgments, in this particular case, for diagnosing problems with your car. The system is asking, what is the problem? Well, my car is making a strange noise, so I select that choice. Does the noise change between standing still and driving? Yes, it does. Does the noise change on a different type of road? Well, no, in this particular case, the road doesn't make any difference. Is the noise a squeal? Yes, it's a squeal. Is the noise most obvious when starting the car? No, for my problem, that's not the case. Is the noise most obvious when braking to a stop? Yes, it is. Well, the system has come to a diagnosis of the problem. And the diagnosis is that the brakes may be glazed, the rotors or pads of disc brakes, or the linings of drum brakes should be inspected for glazing or dirt.
Okay. Now here in this particular case, this is again for clarification, how does this differ from, say, just a strict yes or no decision-making process, getting you down to the point where that someone has literally put in all the yes or no answers, get to the final point? Are there judgments and valuations put on each one of these decisions?
Now, the real difference that comes through expert systems as opposed to other programming techniques is what Jerry was talking about earlier, is the way that the system is programmed. In this particular case, the case of building rule-based expert systems, as they're called, the knowledge that goes into it is in the form of a collection of rules, the little pieces of information that chained together can build up to make decisions.
And these rules come from where?
They come from an expert, somebody who knows how to fix cars.
Now, behind this, is there a generalized tool that, say, could be applied to not only automobiles, but, say, fixing refrigerators?
Absolutely. What's behind this is a tool that can take these rules, these little pieces of information, for whatever context you're in, and tie them together to make a decision or make a judgment.
Now, is this general enough to be applied to virtually anything? Is any kind of a
well, virtually anything is
in the sense that if you had an expert that would come and write rules about, literally anything an expert write rules about, could this system apply to that?
The fact is that expert systems are being applied to a very broad range of applications. For example, there was one developed at Johns Hopkins for diagnosing poisoning situations that you can have on a hotline. When somebody calls in, you find out what to do about.
We've seen that here, in fact. Jerry, we have just about a minute left. You mentioned that at Lotus you are working on some ways to use AI, whatever it is, in application software. Give us a clue as to what areas where we can see coming up.
Well, I think what we're going to see is improvements really in three ways. The first is new classes of applications and products. And of course, I'm not about to pre-announce anything, so I have to be somewhat circumspect about talking about that. But we're looking into areas of flexible databases, just certain kinds of decision support systems, programs that will help you to keep organized, help you to carry through rational processes that typically are easier for machines than for people. Reasoning aids.
We're out of time. I'm awfully sorry. Now, going back to the natural language aspect of artificial intelligence, one of the leaders in the country is Stanford University, Professor Terry Winograd, and our reporter Wendy Woods went to Stanford to talk to Professor Winograd.
Professor Terry Winograd of Stanford is today working on two projects, one programming, one political. The first is a natural language for programmers, which enables them to use simple English words referenced to the kind of work the software will be doing.
The whole quest has been to move away from having people give very specific details of what the machine should do to putting things more in the terms that make sense to them in their world. If I'm doing payroll program, I want to think about people and payrolls and money. I don't want to think about disk files and records and who knows what's in the computer.
His second project concerns funding for AI research. He's worried that too many of his colleagues are being lured into lucrative Defense Department contracts, detracting them from basic research into AI.
The Star Wars in particular has a very specialized spectrum, and I think it's going to distort research to focus much of the money, huge amounts of money, on those particular technologies which are for, as I said, very fast radiation-hard kinds of computing.
Currently, up to 50% of computer science research is supported by military grants, and only a fraction of computer scientists have refused them. Professor Winograd and dozens of other computer science professors are circulating petitions asking that their colleagues not accept Department of Defense Star Wars funding. Their belief is that it will drain money from AI projects with practical applications, increasingly through the rest of the century. For the Computer Chronicles, I'm Wendy Woods.
Joining us now in the studio are Gary Hendricks, Vice President of Advanced Technology at Symantec, and next to Gary is Dr. Hubert Dreyfus, a professor at UC Berkeley, the author of What Computers Can't Do, The Limits of AI, and a new book entitled Mind Over Machine.
Hubert, I'd like to start with you and say, let's just say, what are the kind of fallouts you're going to see from AI in terms of useful products for people?
Well, it's not really my field. I'm a philosopher. I'm more interested in the limits of AI.
We'll start at the bottom end.
Okay. Well, I don't know about the fallouts. I'm on this show to find out about the fallouts.
Okay.
So what I want to say is that you can't use what's called symbolic descriptions and rules and inferences to make computers intelligent like we are, which doesn't mean that you can't find many uses for them. And for that, that's not my job.
Now, what's the reason that you can't do that?
Well, the reason, I think, is that people begin by using rules when they're learning some new skill, but as they get really good at it and develop a lot of experience, they recognize the situation they're in as similar to one that they've already been in, and they just do what worked before. And therefore, they don't need to analyze the situation. In fact, analysis is really for beginners. Intuition is for experts.
So that's where the difference is, in intuition that comes into it.
Gary, do you disagree with that?
Well, I think there's some truth in it, to be sure. But we have to start with the premise of what's the enterprise that we're at. Now, one enterprise is the scientific one of trying to push AI to the limits to find out just exactly what a machine is, in fact, capable of doing. Another is to take the body of techniques that have been developed so far and try to put those into useful products. And here we're paired up a philosopher and a very pragmatic person. My own view is that we haven't nearly reached the limits of what we can do, and what we need to do is take those things that we have discovered, put them into machines, and make practical tools for people.
Gary, there's been a lot of activity around Q&A. Can you show us that product?
Oh, I'd be really pleased to. What we have here is the top screen of the intelligent assistant, unlike the
I might have slipped through, by the way. This is called Q&A.
Q&A, that's right.
What we're taking a look at. Go ahead.
Okay.
The system that you saw from Texas Instruments a minute ago had you make selections from a menu of choices. That gave a great deal of control over what could be said. Here we just let people type in questions pretty much the way that they would like, and we go through, you can see the flickering cursor, to analyze them. After they've been analyzed, we understand what the user wanted to do. We then automatically write a program to produce this result by looking at the database and formatting the data. And just to make sure that we're in sync, another program looks at that program and translates it back into English.
Specifically, what's it doing?
So we had here, I want to find the forms for salespeople who earn more than $15,000 and display them for me. And it translates this into select and view the forms on which the department is sales and the salary is greater than $15,000. And after I see that these two are in fact in agreement, I press the button and away we go to the database to pull up the first form which displays information. Now we can step through these one at a time or zoom in on a whole set of them. Having pulled these up off the disk, I can go down and pick a particular one and then zoom back in on that one as an individual. Now, the interesting thing about natural language is the ability to ask follow-up questions, particularly using pronouns. So the next question that I'm going to ask here is, now I want to see a report that shows the address and salaries of these people. The "these people" refers back to those sales folks who are earning more than $15,000.
Now, let's stop for just a second now. Do you feel like an untrained individual can come here and just type any sentence?
Well, you certainly can't ask what's interesting on TV tonight and expect it to work.
Let's say it's around the database. I mean, is there going to be a dialogue going back and forth about, well, I don't understand this, and please tell me about this, or because obviously there's if you type the right kinds of sentences, they can be parsed properly. So what is your feeling? What's your experience so far with that?
We're certainly not able to parse 100% of the sentences that are typed. But if your purpose is not to break the system or to push the limits of AI, but rather to get a job done, and you sort of cooperate with the system, then the probability is very high.
Is it a training process that goes both ways in a sense?
It is.
You've got some examples,
you teach the system, and the system teaches you. And we'll see that in just a moment. Maybe we could finish this one just quickly. We asked that these be sorted by state, and we also wanted to see the totals and averages. It translates that into the internal query. We go off to the database and pull the information up. And now into the state of California, we get the employees there with their addresses, their salaries, the total for salary, the average for salary, and then moving over spreadsheet fashion, we get the same thing for the field that was calculated on the fly of salary plus bonus. And then also spreadsheet style, you can walk down through the whole report and finally get the grand totals and the grand averages.
Okay, show us the teaching part here, Gary.
All right, if we take another sentence, that doesn't have a word in it that's known, that has a word in it that's not known, it'll stop. In fact, I've asked if an employee has a salary between the average Harvard man's and John's, do something, and it doesn't know the word man. At this point, I have a number of options. One of them is to teach the word, so I'll select teach. I'll select to teach it as a synonym, and now I'll say that man is a synonym for male, at least in this database. And having done that, we restart the parse process, and this new definition has been placed in the lexicon, so it'll be there next time we want to ask a question using the word man. The question itself is rather interesting. If an employee has a salary between the average Harvard man's and John's, let me see his evaluation and review comments, because in an ordinary database management system, you'd have to ask 3 questions to do this. First, you'd have to find the salary of the average Harvard man, then you'd have to find John's salary, and finally, do yet a third pass after writing down these intermediate numbers. This does it all for you.
It also has a problem with John here, apparently.
Yes, it does, because there are 2 Johns in the database. It tells us about that. Now we can press a button and it pulls up a little display. If we know which John it is by name, we can just select it off. If we don't know, we can zoom in on the forms for this. This one makes 32,000. The other guy makes 100. That's the one that I wanted. I'll select that John, and now we'll make the third pass through the database, and here's the result based on that computation.
So there's an important difference between this and just a keyword type of a search. You're actually trying to take the sentence apart and figure out what the pieces are.
It's just like what you do in about 7th grade in parsing.
Dr. Dreyfus, we have just about a minute left. Now, from what you've seen in this whole program, the expert mechanic thing and so on, have you changed your mind at all? I mean, aren't they impressive demonstrations of some degree of artificial intelligence?
They are impressive, but I haven't changed my mind because I never thought they couldn't be impressive. Expert systems can do about 80 or 90% as well as the experts in a field. I would have called them competent systems. I think they're misnamed. But once you are willing to settle for competence, which is important and valuable, you can then use rules and inferences to make these competent systems. But it's a mistake, I believe, to think that if you just work harder, you can get to expertise. You can get that last 15%. And in some areas, one doesn't care. I mean, if you're going to see a doctor and you're sick, you would like to get a doctor that was 100% expert if you could. But if you couldn't, I'd rather consult one of the medical expert systems than my general practitioner, because I hear that they're really better. Another thing, if there's time.
Real briefly.
Okay, there are 2 kinds of expertise. There's a calculating kind, and in that area, you can even do better than people. But most kinds of expertise is of this intuitive kind, and then you settle for less.
Gentlemen, thank you. We are out of time. What are the limits of artificial intelligence, and is intelligence uniquely human? We asked our commentator, George Morrow, for his thoughts.
Artificial intelligence. Such an overly ambitious name for any discipline. One day, when we're all more computer literate, this expression will take its proper place with other classic contradictions, such as postal service or military intelligence. How could such names such as expert systems or artificial intelligence ever have been coined in the first place? Well, my theory is that in the late 50s, when university-based computer research was largely funded by the military, these names were invented to impress the granting agencies. As often as not, this type of research had little, if any, connection with reality, and the more ambitious the sound of the project, the better chance it had to be funded. Now, much of today's AI-type software is quite novel and very useful, but none of these products will be able to live up to the image that the term artificial intelligence invokes. Why not, as Dr. Dreyfus suggests, call an expert system a competent system? On the other hand, if a vendor insists that one of his products is intelligent, we should insist that the product take a standard IQ test and that the score be affixed to the package. That's how I see it. I'm George Morrow.
In the Random Access File this week, it's a new year and projections are already being made as to what kind of a year it will be for computers. Some industry watchers are saying 1986 may be the year that speech recognition finally comes into its own. There are three major speech products which could come out this year. First is Ray Kurzweil's Voice Writer, a word processor that you can dictate to. It has a 10,000-word vocabulary. Kurzweil says it just about works in real time. Speech Systems of Tarzana, California is expected to introduce a similar product this year. It will have a 5,000-word vocabulary. IBM has a speech recognition project called Tangora. No word, of course, on when that may become a product. Major research projects are underway at MIT and Carnegie Mellon to develop talk writers, and the Japanese are also investing heavily in speech recognition technology, with NEC, Matsushita, and Toshiba working on new talk writer products. One major event of the new year will probably be the long-awaited introduction of the IBM Lap Portable called the Clamshell. Inside word is that there may be two versions of the laptop, one with a 3.5-inch drive and one with no disk drive. The IBM Portable with the microfloppy drive will reportedly come with a utility called Xcopy that will let you copy any software from a 5.25-inch disk drive. The significance of IBM moving ahead with a 3.5-inch drive is that it seems likely new IBM desktops will also convert to the smaller drives, thus setting the stage for the disappearance of the old 5.25-inch format as the standard. The other major bit of news due out of IBM this new year is probably a new graphics version of its TopView user interface, though some reports say the new TopView 1.2 won't be out until 1987. Paul Schindler's here now with this week's software review.
It was for moments like these that someone invented the automatic telephone dialer. What a pain to look things up. The same thing goes for computer communications. There are, of course, lots of modems that can dial the phone and lots of software capable of running them. Now there's a breakthrough product called PFS Access. You'll recognize the opening screen and function key assignments. Although software publishing buys its software from outsiders, it imposes a standard user interface on them. The problem with every other communications package is setting up logon procedures. Here, no sweat. Turn on the recording feature, log on as you normally would, and it takes everything down for you. You don't even have to remember to ask PFS Access to save your session. It automatically saves every session. For regular communications users like me, this is great stuff. Now, PFS Access isn't perfect. It lacks some flexibility in uploading files. And darn software publishing, it's copy protected. And that makes it a real pain to use. But the gain is worth the pain for PFS Access from Software Publishing in Mountain View, California. For the Computer Chronicles, I'm Paul Schindler.
Well, we've heard about it for years, but the National Computerized Yellow Pages is finally a reality. It's actually called American Business Lists, and you can access it for $15 a month plus $1 a minute connect time. The company says it's the equivalent of having a national Yellow Pages directory with 6 million pages. That's it for this week's Chronicles. We'll see you next time.
The Computer Chronicles is made possible in part by a grant from AFIPS, the American Federation of Information Processing Societies. AFIPS, sponsors of OAC 86, the nation's leading conference on business technology. For conference information, call 800-OAC-1986. Exploring today's business solutions. Additional funding is provided by McGraw-Hill, publishers of Byte. Byte's detailed technical articles on new hardware, software, and languages cover the latest in microcomputer technology worldwide. Byte, the international standard.